welcome to another coding session. Working on our language Bangalang. Here's some source code for it. It's a low-level explicit procedural compiled language that can run code on the CPU and the GPU. And at this stage I feel like it is all of those things, but it's not really complete, feature complete. The core of it is there, but it's still rough around the edges and still missing some things. So I've compiled this big old list of all the things that I want to do. And I feel like once this list is kind of nailed, probably some more things will get added along the way, but once it's nailed down, that's when I'm going to say, okay, I'm happy with this language. And one thing that has been overlooked for such a long time is the fact that we don't have unsigned integers. We also don't have enums. I guess that's the big other kind of type that we don't have. But unsigned integers we should really have. So that's what I want to add now. I believe the first place we need to go is type checking. Types, I guess, would make sense. Yeah, this is where we have our lists of all of our types. And so it's a numerical type, unsigned. We have all the signed integers here, so let's add the unsigned. And we also have the cint, so let's make an unsigned version of that. Okay, and where else do we want to put them? They are not floats, they are integers. So we'll put them there, and the unsigned also. And these are just the signed ones, so we want a list of unsigned, which is all the new ones. So now we've updated our lists. I kind of want to make sure that everywhere we use these lists, we're using them correctly now that they have the extra types in them. Oh, this looks like tests, is it? Yeah, these are the tests. So yeah, we want to test these types. So that's good. What are we doing here? This is our assignment. So we're saying that numerical types can be used with assignments other than just the regular assign. You know, like modulo assign, add assign, all these kinds of things. So I think unsigned integers should be fine to use with all those as well. When we do a call, this is where we're doing like a cast, basically. We can do explicit casts between different kinds of numbers. Conversions, and we want to be able to do those with numerical types with unsigned integers as well, so that's fine. Negation, you should not be able to negate an unsigned integer. That doesn't make sense, I don't think. So here we're saying all numerical types can be negated, but if we get our unsigned integers, so I guess if it's not numerical or it is unsigned, we cannot negate. Possibly we could do that in maybe a more efficient way, but that'll do. What is this? This is a right-hand side expression. We're saying all sort of binary operators can be used. So I think it's all the same operators that other numerical types can use, but I think that's fine. They are considered an any number, so that's fine. That's it. Okay, so I think for those we're all good. Close all these. So yeah, type is where we had the lists. So let's go to integer types. That's not used in many places, just here. Yeah, they are they're integers. So this is type coercion, by the way. This is also where we had the any number just before. So basically it's saying if we're trying to test whether two types are compatible, and one of those types is a numerical type, including our unsigned types, and the other type is just any number, then it should succeed. That's the idea. Because numerical types are number types. And in the same way, integer types are integer types. So that's all good. Let's check. Well, this has not actually changed, but I kind of want to find where we use these, because that's probably where we need to use these as well. Okay, so here we're saying that signed integer types can be nullified by saying equals 0. This is in GLSL, I think. Yeah, this is GLSL generation. I'm pretty sure we could do that just for all integer types. And we do need to do for non-integers later, but I think that should actually work. And what do we have here? This is assignment also. This is x86 assignment. So here we have, we generate different assembly depending on the type. Now I think for signed and undersigned, it's so similar that we could combine them. Unsigned. So maybe if I go or unsigned, and let me just say generate assignment integer. We go like this. So what do we need to change? Addition and subtraction are exactly the same for signed and unsigned. Where it changes is multiplication and division. So for signed, we have this I prefix, and for unsigned, we do not. So first we need to figure out whether we're talking about signed. Do we have a data type? Here we go. There's the type node. So if the type, I guess if the first letter is I, that means it's signed. But there's also the C in its. So maybe we'll do, this is a bit inefficient because we're going to do this again, but let's do this because that covers the C int as well. And then we'll have this prefix, which is if it's a signed integer type, light, it's an I, otherwise there's no prefix. That way we can go prefix goes here, so the I will only appear for signed integers, and then we do the same thing for division, like so. Hopefully that takes care of that. We can go to the next spot. This is conversion. So here I guess we also want to know whether the source and destination are unsigned. And here we're saying if the source is any kind of integer, I think that's what we're saying. If it's any kind of integer, the alternative is that it's a float. And then this else should not happen, but let's put an assertion here because it should never go there. Failed to to generate conversion. I feel like there's some other places as well. If we're in here, probably that, and then also that. Okay, so hopefully that should cover in all of our cases that don't work. Okay, so if the source is an integer and the destination is also an integer, and the destination size is bigger than the source size, then we need to move to a bigger register. If not, it's actually a no-op. Converting an integer to a small integer is just a case of referring to it as the smaller register. Because the way registers work is a 64-bit register and an 8-bit register, they're actually the same memory. So if you use the 8-bit register name, then you're just referring to the lower, higher. You're just referring to the first. I don't know about Indianness and crazy stuff like that. You're referring to the first 8 bits. So effectively, you're just truncating the register. So that's a no-op, it's fine. When you go to a bigger register, depending on whether it's signed or not, you need to extend. So this is a signed extend. So that's going to fill out the rest of the bytes in the bigger register so that it still is the same number. Okay, but if we're talking about unsigned, we need to do it differently. Because this is, SX is signed extend. There is also, I believe it's a 0 extend, which will just zero out the higher bits, which is all you need to do for an unsigned integer. So that should take care of that. If we go into a float, then it's all the same. So it's like convert signed integer to it's SS precision. I can't remember what that S stands for. A scalar, I think, because these are SIMD instructions. So scalar means we're just talking about a single float. So it's a single float of a certain precision. But I did a bit of research and there is not an unsigned version of this. So that conversion, I'm just going to assume that it's coming from a signed integer. And if you provide an unsigned integer outside of the range of signed integers, like too big, you're going to get a weird result. And too bad. Okay, but if you're going from a float to an integer, this is float to float, so float to integer, then again, wait. Yeah, so this conversion also assumes that it's signed, but again, I'm not going to do anything about it. So if the float is negative, or I don't think a float, I guess potentially the float could be bigger than what can fit in the unsigned integer. What could be bigger than what could fit in any of these. You're just going to get a weird result, and too bad. That's pretty much it. Okay, so that's conversion. This is also conversion. And this is our expression. So this is a binary expression, right? So again, I think I'm going to say that we will do this for signed and unsigned. And we'll make it like that. So here we have, again, the imul and the idiv. And we have this less than greater than business. And that's also dependent, like less than greater than, this notation is for signed integers. It changes for unsigned. So like we did with assignment, we'll do something like this. But then we also want to know what less is and what greater is. So if we're signed, then less is L and greater is G, just like we saw before. And the terminology for unsigned is above and below. So less becomes below, greater becomes above. So let's put less here and here. And greater goes here and here. I did also read that this affects jumps. So yeah, like do I have like a JG? Not in Bangalang code. Yeah, we do, we have a JG. And also for our bounds checking, we have J and L. Yeah, bounds checking. Oh wow, look at this. This is the old project. So is that. So for bounds checking and for assignment, I mean, it all looks like it's to do with the SIMD instructions. And JL, bounds checking. Yeah, I think it's just bounds checking. Okay, so we're gonna have to look at those later. So this is the prefix. And here is prefix. Okay, so I think that covers all of them. All of the places that I can think of that need to handle unsigned. What's this error? Type node. Oops. So we have two choices. I guess I'll use. I mean, if it's an integer expression, they should be the same, right? I mean, this is not conversion, so they should be the same. I don't know why I passed 2 in there. Maybe for consistency, I did it. So that takes care of that. So let's, while we remember, let's do this JL stuff. So this is, we're comparing start expression location. So wait a minute, does compare? So this is actually kind of confusing because, well, actually no, so this is all index stuff, right? Start expression location. So it's either a 0 or start expression node. So it should be the result of an expression. So let's compare. Here it is. Compares operands. Okay, it doesn't actually tell you much about it. What flags it sets and when. But it says you can pass any integer in. Maybe the other place I saw stuff was easier to deal with. Let's check these. So here we're comparing the HLS address location and the limit location. What does the limit location mean? So we're copying the length into it, and we're subtracting 4. Then we're doing a signed multiply. Okay, I think all of this stuff, greater than or equal. It's always comparing this to the limit location, which is something that I fabricate. So I think it's all like, I think it should all be fine. I think, I mean, who knows? Maybe one day it'll crop its ugly, rear its ugly head up with some dangerous stuff. But I feel like this bounds checking is where it really could be a problem. Because this could result in any int. It could be signed or unsigned. So I guess this expression node, it should have a type, right? Start expression type node. Oh, look at that, we do a convert. What do we convert it to? Index type node. Where the hell is index type node? Which is an I64. Ah, okay. So I feel like it's not an issue. Whether that should be I64, maybe it should be U64. But because we convert to it, oh, this is like in a util file. That's why I couldn't find it. Yeah, we also do it for the end expression. So because we do a conversion to that type, that means that these are going to be all good, I think. Okay, we might have to review that later on, but I think it's nothing to worry about right now. That's what I'm trying to get at. So I think that has basically added them, and if we do these tests, it should test those unsigned integers. Type was not found. I think that's because, I think it's in here. Here we go. This is where we set up our program with the built-in identifiers, which needs to include our new unsigned ones. You. Unsupported. Byte size, probably. Byte size, yeah. Because this is where we take our built-in types and we say, okay, how big is it? So again, we need to add these to these lists so that the compiler knows how big they are. ASC int. So CU int is the same size. Okay. Cool. Try that again. Okay. It's running the tests. It's thinking about it. Oh, cannot negate type CU int. Yeah, that makes sense. Non-atomic integer tests. I guess it's like a non... If I find that, it's down here. If it's an atomic integer, but it's one of the non-atomic integer tests. We also don't do these for floats. So maybe just for like unsigned integer types. We don't do negate because you can't negate them. All right, let's try that. Ooh, some dodgy assembly. So if we go to our test assembly line 17, it's a multiply. It's not happy with that. Okay, I'm pretty sure it's mul. If we say mul, maybe I'll go match case and mul. Okay, so imul. This is talking about specific registers. I don't think we do that with imul. Mul unsigned. So this is also, it's talking about DX, AX. These are specific registers that it's saying to use, which is a bit weird. imul immediate. Okay, I don't know. I mean, this is a bit, oh, they're examples. So I think it's like register. This notation, I'm not sure exactly what's going on, but it's with an immediate. Although I don't see any immediates here. Oh, this is, okay, these are, I guess, immediates. I don't know what H is. Oh, there's like 3 operands. Okay, so I don't really know if that's what we use normally for here we go. Imul RRM, register and register raw memory. That's what we normally use. 2 operand non-widening integer multiply. Okay. Mul X, widening unsigned integer multiply without setting flags. Multiplies EDX, RDX with RM. Stores the low half of the multiplication result in RA and the high half in RB. Okay. And then it's got like floating point multiplication, repeating, and then we're like in the references. Okay, so, it seems like this is the kind I want to use, but it seems like it's only for imul. So, and this is also only for imul, whatever this deal is. So maybe we need to use this form, which is AX times register or memory. So we need to put the left-hand side in racks, and then and then I guess the answer is spread over 2 registers because it could be bigger than a single register. But I think we'll just truncate and take AX as the result. So we need to put the left-hand side in racks and take racks as the result. It's kind of like division. And if I go up here, yeah, this is the same. So maybe we'll use that form instead for both, just for simplicity. I guess, I think maybe I need to rearrange my code a little bit for this stuff, but I guess that would be an assignment and also an expression. So assignment, yeah, here's multiplication. So we want to do something more like this, I think. Let's put that there. What are the 2 things that you put into a multiplication? Like the product is the result. I forget what it's called. But this is like the LHS low part. Yeah, I feel like there's a proper term. So I'm just going to put a question mark there for now. So that's dx ax. Dx is the high part, I guess, and ax is the low part, I would say. Operation name. Oh, we don't need operation name because here it's always multiplier sign. So we can take that out. So AX gets assigned from the left-hand side. That makes sense. And this is a mul. So then to operation size. We were putting the operation size in there. But here instead, this left-hand side needs to be... but this is probably like division. It's probably just a single thing that we put here, which could be register or memory. We're saying it's a register, which makes me wonder why we need this operation size, if this is a register. Yeah, we'll put the left-hand side is here, so I guess this is the right-hand side, which we're saying is in a register. And then we move from, yeah, output register. But here it's always rex, or it's always AX is the output, right? Yeah, that's the output, but we want the lower part. Oh, wait a minute. The output is both. The input is just AX times. So we don't need to do this business. This is just assign left-hand side. to AX, and then do the multiply and then put the result from AX to the left-hand side. Yeah, because this is at a sign. And then the result location is the left-hand side location. I think that still holds. Result location. What is even, like, we're assigning this, but this is like a local thing that's never even used after that. So I'm a little bit confused. We're copying from the result to the left-hand side. So then I really don't know why we put that there. But we don't need this result location anymore. I'm a bit confused about why we even had it. So I'm just going to cut that out. I think it's just that. Oh, so we do need this register location. We're copying to a register. Okay. Yes, we have this size here, even though this is clearly a register. So I'm kind of thinking we don't need that. Let's see. I mean, if it complains at us, then it turns out we did need it. Okay, expression should be something similar. Is this also? This is also a register location. So it should know the size, right? I feel like it should know the size. Yeah, maybe I'm going to regret this, but there we go. And here we do need to use a result location, right? Result location is a register we nominated. So I think this is just saying we need to copy the left-hand side into here for these ones. But I don't think that's the case for, like, here we just do a move to it in the end. So let's get this code and put it here and see. So this is multiply. Well, it says register location, but it says copy to non-immediate. That could have something to do with it. Let's name that better. And put this back because that's why. And also for this div, yeah, that's more clear. Does that mean that we can just do the same for this stuff? Because it is like, it does say register or memory. So really I want to say non-immediate, right? Non-immediate location. And then I want to also have this size information, because if this is memory, then it doesn't know how big it is, and we need to put in the size information here. Okay. So that was our assignment. So then I think we also need to put this guy here and also put the size information. now that we're not enforcing it to be a register. Type node, just going to use result. Looks like I use result type node for everything. Result type node. But we need, yes, so we're not going to LHS. We're going to result location. And from a register, so we know the size. So I think we can just go like, we don't need to copy this to a register. If we're doing a multiply, yeah, result location is already a register. So this is copying the left-hand side. Yeah, that's not needed. I think we should be able to do that. I think. I mean, let's see what happens. Whether we get good results or not. Okay. I think that should be just like LHS. So modulo didn't work. I have a feeling modulo maybe didn't work for it doesn't work for floats. Yeah, there was this I8 stuff that didn't work, and it included modulo. But does that mean, that's like modulo assign did work. So what are the values that we put in here? It's like 246. And, and modulo, here's the modulo test. Modulo 3. So it's like value 1 modulo 3. So what's value 1? 4 modulo 3 should get 1 as the result, right? I hope, if I remember how to do modulo. God damn it. Here we go. Yeah, it should be 1 as the result. But apparently it's not. It's not like it said it couldn't do it. Didn't complain that like this is not valid or something like that. So I don't know why that would have failed. But I'm just going to allow that to fail for now and add it to do. Something to think about later. Let's try it, because I'm really curious about these multiplies. Well, it seems like the multipliers succeeded, right? Okay, that's a little bit concerning. The screen is black. Oh my God. The screen is black and it could be anything. But I'm not even using Unsigned. So the only thing that I changed really is this, right? So now I'm curious if I do like this so that it uses the old code for signed integers. And I'll do the same for expression. Was that it for the old code? Yeah, it looks like this is all green. So that's the old code. Does it work now? Did I ruin everything with that multiply? Apparently I did. Apparently I did. Huh. Okay. But it seems that it worked. Oh, I did not. I'm kind of surprised that that worked. Okay, I mean, if it works, it works. I mean, the test's passed, but now I'm a bit dubious because the test passed for signed as well. But then later it seems like it did something wrong. So I have a feeling that something here is not right. Let's multiply a sign. So it makes sense that we put it into the left-hand side location at the end. Again, I'm not really sure why this result location, because we don't use it again after that, right? Oh, that's not even passed in. It's just a useful thing for this. So this is really pointless and confusing. So if I run that again, it's probably fine. Yeah, I'm not that confident about this unsigned multiplication, to be honest. But that seems to work. And I think we're just going to leave it like that for now. And I'm going to say, like, test this stuff because I do not trust it. Okay. Speaking of that, I also want to put, we have like a list here. So we don't have any conversion tests. So let's put some tests in for that. Okay. So I feel like that's unsigned integers done to the degree that I can be bothered doing them right now. So I'm going to cut those out, and we have a bit of time left to do some things. I think maybe we can squash some of these bugs. So this one here, GLSL kernels, I believe that must be Boomstick. Yeah, here's Boomstick. So I think this was like, if I tried to do this, which you would think should work. We might have to turn off the tests again. Yeah, we get raw is not defined. But it should be defined. So why isn't it defined? So here it's looking for it as if it's an identifier, but it's a member. So it should have gone into this member stuff and done this. And it would never come out of there. We'll have an assert. But yeah, this is an else. So it's decided that it's not a member. Okay, I think it's because this kind of, it checks that what we're passing in is actually an identifier and it has children, and then it tries to go down to where it should find a child identifier, which would mean that it's a member, because in the AST, the thing that it's a member of should be a child of it. But in between, there could be dereference and reference nodes. And in our case, we're doing an index. So there's an index node, which I think should also be allowed, or should also get skipped over here. There we go. So now it works. Yeah, the FPS is terrible. So much worse when I'm recording. When I'm not recording, I get like 6,000, 8,000, so much higher. So that's pretty much it. I mean, maybe we'll put those like that just to show that like it's working. Okay. So that fixes that bug. Next one, require equals for static def proc defs. So that's like I can go foo proc strings.print line hello foo, and what will happen? Spot the mistake. Index 2 is out of range. So we get a crash when we're generating our procedure. And the reason is like this looks legit. And in a lot of languages, that's pretty similar to how you would do it. In my language, you need to put in equals. And then we get our hello. You need an equals here because it's the same syntax as like this. Name colon type equals value. Name colon type equals value. That's the idea. So I think when we come across something like this, we should enforce that there is an equals. That's kind of my idea. Like this should not be valid code. Yeah, but this I think should. So this is forcing to say like that this is a stack variable, aka a pointer. This is a so this is just setting up a pointer to a procedure. So that should be legit. So let's set that up as a test as well. So if we have bar, then we should be able to just declare it like that and then go bar equals foo and then call bar. That should be legit. If we do that, we should get hello printed twice, but we do not. We don't get an error, which is interesting. Oh, because we don't call foo here. Okay, yeah, we get hello printed twice. All right. So that should be legit. So for these, you don't need to immediately assign it. But for these, you do need to immediately assign it. So that's causing a crash in our compiler right now. But it should give us an error saying you need to put an equals. So that is in type checking and assignment. Type checking? Yeah, type checking, I think. Type checking assignment. This is where we've decided that we're declaring a procedure. So interestingly, we don't take into account the allocator that's being used. We've said it's not a member. I think it should be not get allocator Yeah, this is I guess this is something that I've used quite a bit, but I don't really like. Here we get in the left-hand side allocator. So this is where we're doing some checks for it. If it's new. So heap and VRAM should get denied here if we're declaring a procedure. Because it needs to be a pointer. Interesting. Pointed to a, yeah. That's probably also an issue. Issues everywhere. This, I don't like having this explicitly put in a few places. But it is. So usually what I do is say GLSL is temp here. I don't want, like, GLSL is just like a way of setting up a procedure. It should not affect, it should not be explicitly mentioned in the compiler like this all over the place, is my feeling. So we've broken something because we did not put an OR in here. So now only static variables should go into here. Interestingly, it did work. So we're saying it has a type node procedure. There is static procedure or is static procedure statement. See, and that's like checking these things. Yes, getting the type, making sure that it is procedure. And if it's a member, and it's a member of something that's not a module, then it's also, so I think that's exactly what we want here, actually. Yeah, I think that's, oh my God. I think that's basically what we want. Is static procedure left-hand side node. Where is that used? Looks like all over the place, so let's just keep it. Okay, so if it's a static procedure, then we go in here. And so this is like with, if we're greater than 1. So I think actually, so when we say that the children is greater than 1, what we're basically saying is like, does this assignment have a right-hand side? Are we assigning to it, or is it just like this where there's no right-hand side? We're not going blah, blah, like that. It's just left-hand side. This is also just left-hand side right now. So if it's just left-hand side, see down here, we're saying if it's a procedure and it's extern, you know what? Just to keep this kind of stuff together, I might put this like here. So here we're saying if there's no right-hand side and it's not extern, oh, we need to move this left-hand side type node up. Probably below this, because I guess it would get generated by that sometimes. Yeah, if if we don't have a right-hand side and it's not extern, then we say procedure must have a procedure body. So yeah, there's no right-hand side and it's not extern. Otherwise, there is a right-hand side and it is extern. That's also a problem. Extern procedures cannot have a procedure body because they're defined elsewhere. That's what extern means. So I think this is our extra check that we need. What do we got down here? This is complaining because the left-hand side type node. And I think there was a reason why I declared this down here, because it can get this is kind of like setting it up sometimes. So it does get a bit complicated. So I think to simplify things, let's just go like this. We won't save it. And we'll put this inside here. Oh yeah, I can see because there's no change here. This is where it used to be. What happens then? Crash. Okay, that's not great. So there's no type. Because here we haven't established that we're talking about a procedure. This is for procedures only. So I think this is enough. We just want to know if it's a procedure. We don't specifically want to know if it's static or not. So let's say it just seems a bit weird that we're doing it like this. There's no type or the type. If there is a type and that type is procedure. This, I feel like I don't like this, so I'm just doing get type over and over and over. But it's only for procedures we want to do this. I think that was the problem before. We're doing it for everything. Procedure bar must have a procedure body. But that's not the one we want the procedure body for. But it is stack. I think again, it's like if we're dealing with a static procedure. So maybe we'll just leave that in there where it was, and we'll say if we're dealing with the static procedure, and length equals 1, if we've got a static procedure, well, this is a cheaper test, so we'll do this first, and we're dealing with a static procedure, and it's not extern. We need a body. So yeah, procedure foo must have a procedure. That's better. Foo must have a procedure body. But bar doesn't need one. Okay, there we go. 2 hellos. So that turned out to be a mission. But that's basically what we added, wasn't it? And we changed that to static procedure. Yeah, I think that fixes it up. Not too much work actually in the end. So that gets rid of that one. We're over an hour, but I think I might just take out this one as well because it's like such a simple, it's a nice, easy little thing actually. When we're parsing multi-line comments, so parsing, so actually what I mean is like tokenizing multi-line comments. So here we found this, means we're in a multi-line comment. And while we're in it, if we come across a single line comment, then we read it and then we continue. But the problem there is, in my source code, if I say hello, and then I go like this, what would you expect to happen? I mean, from the highlighting that the IDE has done, it's expecting that this is the end of the comment. And here's code again. But if I go like this, I get a black screen. I wasn't sure what was going to happen. But actually, because in here it reads the single line comment, which is everything up until the new line character, including these characters. So it's doing that. Yeah, it's doing that here. And then when it's finished doing that, it continues the loop. It continues as if it's still in the multi-line comment. And I think that's wrong. So I think the way to resolve that, read single line comment. So I don't think that needs to be its own procedure actually, because it's I only want it in one place now. I'm pretty much saying that should not be there. So that should be like that. Okay. So maybe because I don't want to cut out the init, I'll say like blah I64 equals 43. There, everything works fine. Because it knows that this is the end of the comment now. I think that's better. It's still like if I have a string in here and the string contains that, it's still going to work. And that should stay like that, I think. It used to be this and this, that the things. So I need to update a test actually, the test right at the top. See, it was testing both of those cases. But I need to take that one out because that's not a thing anymore. Okay. I think that's enough for this session. We fixed a few bugs. We got unsigned integers. I'm still not really convinced that unsigned integers are working well. The multiplication especially is like, I'm not sure. But yeah, I think that's good enough progress for now. So thanks for stopping by. Have a good one. Ciao for now.